What are the losses? Already we have covered few topics in this one. So mainly losses of the transformer are classified into two types. One is iron loss, another one is copper loss. So iron loss also call it as a core loss, and one more is copper loss. Core loss, which is mainly in the core of the transformer. So what is core of the transformer? Core, which it will allow the magnetic flux lines to flow through it, and which through the core magnetic flux lines linked with the primary coil as well as secondary coil. So here the losses, iron loss or core loss, are classified into two components. One is hysteresis loss, another one is eddy current loss. So what is hysteresis loss? Hysteresis loss is due to continuous magnetization and demagnetization of the core of the transformer. So because of that hysteresis loss, reversal of magnetization in the transformer core, there is some heat loss takes place in the core of the transformer. So this one, it depends upon the volume and grade of the iron, frequency of the magnetic reversal, and volume of flux density. So it is given in the form of WH is equal to eta B maximum to the power 1.6 F into V watts. And one more, eddy current loss in the transformer. This is mainly due to the when the flux gets linked with the conducting part or core of the transformer, which result in the induced EMF, and that causing small circulating current. So that current or that will dissipated as a heat energy in the core of the transformer. So that heat also considered as a eddy current losses. So hysteresis loss and eddy current losses are the two losses in the core of the transformer. That's why it is called as a core loss. Yeah, and eddy current loss is given in the form of KEB maximum square F square V T square. Even this is also related to the volume of the core, thickness of the core, maximum flux density, then frequency of the magnetic reversal, everything it is related. But we can reduce the eddy current loss and hysteresis loss by properly laminating the core of the transformer. So here thin layers of the stainless steels are stacked together to make the core of the transformer. So if the laminations are made, then it will reduce the eddy current loss as well as hysteresis loss. And the one thing we need to remember, iron loss or core loss is a constant loss because it depends mainly on the volume of the core, thickness of the core, then magnetic flux density. All these parameters can be kept constant. And also it depends on the input voltage. Input voltage also will maintain constant while the working of the transformer. So the core loss or iron loss is a constant. Next type is copper loss. Copper loss is a variable loss because what is the reason of the copper loss? It is mainly due to the electrical resistance of the primary and secondary windings. So primary and secondary windings is not a pure inductance or pure coil. Practically it has some resistance. Because of that resistance, when the current flows through that primary winding, voltage drop takes place or power dissipation takes place. So because of that, losses takes place in the transformer. So it is made up of most coils are made from the copper wire which has resistance. So it always opposes the magnetizing current flowing through them. So that electrical energy, power losses occur as a heat in the primary winding and secondary winding. So it is represented as I square into R. So copper loss vary with the load current. It is almost zero at no load, at the maximum at full load. because maximum current, when the load increases at the secondary part, more current flows to the secondary part, so more power dissipation takes place in the secondary part because it's related to primary I1 square R1, secondary side I2 square R2. So core loss is a constant loss. One more another term, output can be written in terms of input minus losses divided by input. So there are two methods. Either you can write output as input minus losses, or input you can write it as a output plus losses. So full load efficiency output divided by input you can write it as a output plus losses. So what is output? Output V2 I2 cos phi 2 divided by V2 I2 cos phi 2 plus Wi plus Wco. So these are the two losses in the transformer. Wi is core loss and Wcu copper loss. So at any load other than full load output of the transformer will vary. Copper losses also vary. The iron loss will remain constant. So because whatever the load we are changing at the output side, based on the load, the current flowing through the secondary part also changes. So when the current changes, copper loss also changes because it is I square into R. So here we need to calculate the efficiency for any load. How to calculate for any load? So we have to consider one load factor X. So that load factor X is the secondary current at any load divided by full load secondary current, or we can say X is the load factor that will be multiplied to the output as well as input side, so that we can calculate efficiency at any load. So here output power is X into V2 I2 cos phi 2 core loss Wi, but copper loss also should be represented in terms of X square into Wcu. X square means it is I square into R. So X square means as the current changes, it is I square. So we need to represent as X square Wcu. Copper loss will vary as square of the current. X into Va cos phi divided by X into Va cos phi plus Wi plus X square into Wcu. So Va already they have given what is the rating of the transformer. So you need to multiply X value depending on the load. Va they have given voltage into ampere, V2 I2 or Va term, voltage into current term, Va ampere. Cos phi also given, that you need to multiply. X square Wcu, that load factor should be multiplied to the R. And next type is copper loss. Copper loss is a variable loss because what is the reason of the copper loss? It is mainly due to the electrical resistance of the primary and secondary windings. So primary and secondary windings is not a pure inductance or pure coil. Practically it has some resistance. Because of that resistance, when the current flows through that primary winding, voltage drop takes place or power dissipation takes place. So because of that, losses takes place in the transformer. So it is made up of most coils are made from the copper wire which has resistance. So it always opposes the magnetizing current flowing through them. So that electrical energy, power losses occur as a heat in the primary winding and secondary winding. So it is represented as I square into Next question.